V.Thiagarajan, retired Deputy Chief Engineer from Indian Railways. So in this video, I'm going to discuss something about the layout designs for the station yards in Indian Railways. Here I'm going to cover mainly about the crossover connections, how the crossovers are or laid, and for that what are the parameters are required for fixing geometry on the field. Along with the explanation, I am going to discuss about some numerical examples also. So it is a part 3 video, and part 1, part 2 also can kindly go through. There I've been discussed about the introduction and various design consideration for designing of our layout in the first part, and part 2 I discussed about the this is some portion of connection, that means connection to the divergent track and the parallel track connections, how they have to be performed, and for that how the parameters are being calculated. All those things we have seen. So before this video, kindly just see those videos so that you will be able to proceed further. So whatever I am going to discuss in this video. So here this is the station yard already. You may be knowing, many of you, this is a railway station yard. So many connections are there. As far as crossovers are concerned, this is connecting the two parallel tracks. If you are introducing a line, it's called a crossover. It has two turnout on both lines. Connection means, simply connection means there is only one point will be there. From line only one point. If there are 2 points on crossing, in both lines, if there are, that is called crossover connections. And these are different type of connections, and first 5 type of connections already we have seen. Divergent track connections and connection to the parallel track. So now we are going to see the crossover connections. So there we have different type of connections. These connections we are going to discuss here, and also at the end of the video I'm going to discuss something about my website. I'm having a website, V.Thiagarajan.com. There I have some application for layout designs. So that also we'll discuss some amount of applications we'll try. So we are able to get the required parameters using these applications. So, and also just I want to recollect, this is about the Cinderella method what we are adopting as well as our layout designs are concerned. Where points on crossing, this is a points on crossing complete the layout. In that we adopt the Cinderella method. So we take Cinderella of the main line, Cinderella of the turnout line. This is called intersection point. This is A distance from SRJ to point of intersection, A distance, and intersection to the heel of crossing, B distance, like that main line and the turnout line. So we forgot to all gauge lines, and only we take the center line portion, and with that we are trigonometrically try to solve for various parameters required for fixing the geometry and the field. This is already we have the standard dimension table for different type of points on crossing, and what are the this one value. A dimensions how much, B dimension value. You can straight away you can just take the value from this table, and you can plug in the formula. We'll be able to resolve for the required parameters. Now we'll go to the next subject. This is a crossover between the straight parallel tracks. That's a normal distance. So this type of connection, already we have discussed in the beginning itself. I explained for understanding purpose about the layout. So this is a crossover between straight parallel tracks with a normal distance. That means normally in the passenger station and all, the station, the lines will be closer. That means there will be minimum track distance will be there to accommodate more number of lines. If that is the case, normally we used to provide the connection straight away without any curve in between them. So we'll have a straight connection. So the previous case we have seen the connection. So there one points on crossing, we will have, and we will have the connection with the another the parallel track. But here it is crossover. That means there will be 2 turnouts in both lines, and that will permit both through movement as well as turnout movement. This is called crossover. And here, as usual, no, we have to find out the horizontal distance for fixing the the relative position of the two turnout. You must know the distance between the SRJ of one point crossing to the SRJ of other points crossing. Okay, so for finding out now, we have to find out the point of intersection of the 2 points. That means x distance we are finding out. Then so once we find out the x distance, adding the a, here 2a will be there, here also 1a, another points crossing a. So we will add the a distance of both turnouts. We'll have the overall. That means x plus 2a will give you the overall length. Once we know the overall length, when we know the location of the 1 point crossing SRJ, with the reference that we'll be able to fix other points SRJ. So locating this one, inserting the points, we will have the connection that will be straight. Okay. This as usual, as far as this connection, it's very simple. The trigonometry is very simple. You can take this triangle normally, or we'll work it out. So finding out x, what you do. So we know the distance, track centers we know, and we have to find out the x distance. That means what? This tan rule we can apply. So tan f is equal. Suppose we use the angle of crossing is same. Both turnout is same angle of crossing. That is 1 into 12. Here also 1 into 12. If that is the case, so if you take this angle tan f equal to, so d by x. So x equal to d into 1 by tan f. Normally 1 by tan f used to say cot f. And cot f is simply number actually. Cot f is simply number of the points crossing. When we use 1 in 12 points crossing, the number of the points crossing is 12. So simply we are multiplying the distance with the number, we will get the x distance. Once we know the x distance, adding 2a, the same turnout we have, we will be able to get the overall length. Okay, so this is the procedure to find out our required distance of OL. And as far as suppose we want to know the straight distance in between the hill of crossing, so this hypotenuse, so hypotenuse and here d, relating d and hypotenuse, we can use sine rule. So normally sine f is equal to opposite d divided by the hypotenuse. Hypotenuse how much? Here 1b and s and b, so 2b plus s. Okay, so from there you can find out the s distance. So s distance is equal to d by sine of minus 2b will be s distance. So it's very simple calculation. Okay, we'll be able to do as far as crossover between straight parallel tracks with the normal distance. Okay, so if you go to example, okay, here for introducing a crossover between two parallel tracks, 60 kg spaced at a distance of 6 meters with 1 in 12 turnout on both sides. Calculate the required distances for setting out the layout. So crossing angle is 40, 40, 49 for 1 in 12. So both lines we have the same turnout of 1 in 12. So in terms of degree this is, and A distance we are taking and B distance we are taking from the table. Okay. So x distance we want to find out what, so x equal to d cot of I told simply number. We get the distance equal to 72. So 72 plus 2a, a is given 16.989. So multiply 2 in plus 72,000, you will be able to get 105,978 mm. So okay, we are keeping in mm, we are finding out, okay, for better accuracy. And if you want to find out the s distance, s equal to d by sine of minus 2b. So distance is 6,000. So substituting here, we are getting 26.426 meter. So side length hill of crossing to this hill of crossing is 26.426. Okay, this we know. And we know the overall length. So fixing the distance between the SRJ, we are able to perfectly fix the geometry on the field. Okay, this is something about that. So numerical example was for us this type of connection is concerned. Okay, and many time even the open line engineers, PU engineers, so sometime they will have some problem in this kind of crossover, always there will be some kink. When the train is negotiating through the turnout, there will be more jolting and all, and they can check up. So they can work out on this overall distance, whether the relative position is okay or not. We have to check up, or otherwise you have to slightly make some shift to get the record distance. But only this thing, whatever we do, no, it is better to do it in the construction itself, initial laying itself. We should do it. So once we have wrongly laid any layout, so after coming into working, it's very difficult to correct it, because after that there will be a lot of obligatory points. Okay, with reference to this location, signal positions, interlocking, everything will be there. So after completely doing the work, it's very difficult to correct it. So that is why whatever we want to do properly, you think over once, twice, and do a proper design and fix the geometry. Okay, in order. Okay, the beginning itself. Okay, this is what I want to say here. Okay. So the next example we'll see here the same crossover with normal distance. So in this exercise they asked the minimum track distance how much should be, or in case when we are providing 60 kg 112 points and crossing on both lines, and only 8 of points and crossing on both lines. What should be the minimum track distance we must ensure? In this case, we have to take this equation, that is tight equation. We have to take S equal to d by sine of minus 2, because see here it seems to be a larger, but sometime it will be very close. It will be minimum. Suppose when you are keeping the heel of crossing minimum, that is only maximum, you can go up to that only. Okay, you should not overlap. Okay, for keeping the S distance 0, that is butting the heel of crossing of one point on crossing with the other points on crossing heel. If that is the case, what is the minimum distance required that we have to find out. So here, for example, for first case 60 kg 1 in 12 PSC. So in this case we are using this formula, we can find out D. So D equal to 2B sin f. Substituting all the values B and sin f, we are getting 4.72 meters. In case of 1 in 12 turnout, we are providing on both lines, we require minimum distance of 4.72. Okay, and suppose when you are using 1 unit of turnout and on both lines, in this case, so D equal to B sin f 2. Here we are getting 4.63. Okay, but however, as per Sudar dimension, now the minimum track distance, we must ensure 5.3 meters wherever we do new works and all. But existing work, I think they have gone 4.265. Okay, but anyway, nowadays maximum we used to have only 4.72. So when you are providing 5.3, definitely it will be satisfied. Okay, it will be always will be 4.72 and 4.63 only. So there won't be any issues. So this is to find out the minimum track distance, how much in case of 112 points on grass when you use, in case of 112 points when you use. Okay, this is something about it. So next type of crossover between the straight parallel tracks, the large distance, similar to connection we have seen, like that here, in case of crossover with the large distance with the reverse curve, reduction of reverse curve. As I already told you, suppose if we have the straight connection, the overall length of the turnout will be more. That is why for reducing this, okay, to use the space effectively, we can introduce a reverse curve. So in this case, how it is to be done. So this is a detailed drawing of this connection. Here same angle of crossing we are using. Okay, and radius also same. Similar to the connection, so you have to trigonometry, you have to solve for the deflection angle. Okay, deflection of this curve and deflection of this curve. So this is theta, this how much should be there. So So this is actually, since this is a deflection angle, this is theta, when you are keeping it, theta minus f will be this one. So how to find out the theta? So just similar to earlier case, no, in connection, we are finding out. So again, we take this triangle, O1 TP2n, this triangle we are keeping here, that we use the cos rule, that is cos theta equal to adjacent side divided by the hypotenuse. Adjacent side is O1n and hypotenuse is O1 TP2. So how to find out the O1n1? So first we have to find out the O1n. So we are finding out this O1L plus Lm minus Nm will be your O1n. Okay. So actually here in this case, since it is a symmetry, since it is symmetrical, because these are same angle of crossing, same curve. So automatically this common tangent point will be the middle of the track. So this will be equal to d by 2. This is Nm equal to d by 2. Nm equal to d by 2. So we can find out O1L equal to O1L equal to. So let us take again this triangle we take. So first we have to find out O1L. O1L how much? This actually f already we found out now, because this is f, this will be 90 minus f minus 90. I mean we'll be getting this f. Okay. So this is f actually. So in this triangle we are finding out the O1L we are finding out. That is r cos f. That Lm you know pretty well. This triangle. This is f. This is b. So this will be equal to b sin f. Okay. So actually Nm equal to d by 2. Nm equal to d by 2. This we know. So from here, so you will be able to get the equation cos theta. Cos theta equal to this. Okay. That means O1n divided by r. So okay, the O1n1 we are just from already we have the all values. From here we are making, and ultimately we will be able to get this one, that is r cos of plus b sin minus d by 2 divided by r will be cos theta. Theta is equal to cos inverse of this thing. Okay. Then once we know that theta, so we can find out the tangent length. That is this is our deflection angle. This is theta minus f here. This angle subtended center is equal to here only theta minus f. The same angle will be your deflection angle. So then x, if you want to find out the horizontal distance, so again we go for making triangles and finding out the horizontal distances till the point of intersection. So here point of intersection, this point of intersection is the x. Now we are keeping it. Okay. So this triangle, how much? This is b plus t here. Okay. Cos of, and here again t cos theta. This is t cos theta. So similar, same whatever we have, same value only will get this. Okay. It is only symmetry, replica. That is why 2 times of I put b plus t cos of plus t cos theta. Up to this this value into 2 times means we will be able to get this. This is equal to this. That is 2 times of b plus t cos of plus t cos theta. Once we know the x, we can find out the overall length. That is x plus 2a. Here a. So very important. So this is the way we have to solve for the overall length. The distance between the SRG of one point synchronized to other point synchronized. Okay. So we can see in an example also here, a crossover is required to be laid between the 2 parallel BG tracks at 15 meter distance by means of 50 kg, 1 in 12, okay, turnout. The non-PSC with no straight in between. Okay, calculate the required parameters of layout. Also calculate saving in overall length in this layout over the layout with straight line crossing. Okay, so we have to put the normal distance. With the straight connection, the reversal connections. Now how much saving we will be able to get. So that they asked. But here 1 in 12 points on crossing, you have to use 50 kg. Okay. So let us take first reverse curve with reverse curve. So cos theta formula we are applying, and we are finding out the theta first. Theta first. We know R is here 1 in 12, R is 442, 82. Okay, that is R minus J by 2. Centerline curvature. Okay, and B we know we can take from the standard measurement table, and D by 2, that is distance also is given 15 meter by 2. So substituting all value, you are getting theta, that is equal to 10 degree 1434. And once we know the theta, we can find out the deflection angle and the tangent of the first curve. So T is equal to R tan theta minus F divided by 2. We got that is coming around 21.116 meter. Okay. Then again, we can find out the x distance. That is 2 times up to here. We can find out the 2 times will be there. So 2 times of b plus t cos of plus t cos theta. Substituting all the values. We know b, we know t cos f, and t also we know cos theta. So we are getting the x distance equal to 131.441, and overall length equal to, adding 2a with x, you got 165.347. So total overall length in case of reverse curve, how much? 165.347. Suppose straight line, you used to know what to do. Will straight connection. Here simple formula we can use d cot of overall length equal to d cot of plus 2a. That formula d cot of means this point of intersection to point of intersection of other points across it, d cot of t into cot of. So simply number, cot of number. So here 15 meter distance into points on crossing used is 1 in 12. That means number is 12. 15 into 12 plus 2 times of EA. EA value they are given. No, standard measurement is 16.953. So summing up, you are getting 213.906. So in case of straight connection, when we have 213.906 will be our overall length, but in case of reverse curve, we have 165.347 will be our overall length. So the savings how much? 213.906 minus 165.347, we are getting around 48.559 meter savings we are able to get overall. So this is the way, okay, we are designing as far as this type of connection is concerned. Next case is a crossover between straight parallel tracks, the reverse curve, the different angle of crossing. Suppose it's different angle of crossing, how it should be. Okay. But here the problem is, earlier case, 2 times you have taken because it was falling exactly center. This common tangent point will be exactly middle of the track, central length of track. Okay. But here, since this crossing angle is different, it will not be exactly, it will be some shifted according to the angle of crossing. It will be either this way or that way. Okay. So how to go about, how to solve this one? Okay. So this is a detailed drawing you can study, and okay, again, over convenience sake for trigonometry, so we are making some triangles, all possible ways, and try to find out this theta. Once we know theta, directing this one, we'll be able to deflection angle here. Okay. So once this angle is theta, this angle is theta, we will be able to get deflection angle. So theta has to be found out. Okay. So since the angle of crossing is different, we have to separately resolve this portion and this portion, and we have to equate. How to do that? So first we take the triangle O1 NTP2. So O1 N1 TP. This triangle we are taking. This triangle. So cos theta. What is cos theta? We are finding out. Cos theta is equal to adjust side by hypotenuse. Hypotenuse is O1 TP2. Okay. So again, as previous case, So to find out the O1, N1, first we are taking this triangle, we are finding out the O1, L1, and okay, this L1, N1 we are finding out from using this triangle. So adding this thing, total will get minus. Here we cannot get the d by 2. Here simply we are getting N1, M1 we are getting. It is not d by 2 actually, because it is not exactly located in middle of the track, center of tracks. Okay, that is why we are keeping as it is N1, M1 minus this one. Okay, we are keeping as it is N1, M1. So this is your cos theta equation. Okay, that we have to find out O1, L1, L1, M1 and N1, M1. O1, L1 equal to R cos F1, this triangle, and L1, M1, this triangle, this we are finding out, that is B plus 1, including, if we are adding S also we can add if it is there, B1 plus S1 sin of, and O1, TP1 R1, that O1, TP1 is R1, we know, but NM1 we don't know, simply we are keeping as it is. So substituting here, we got, from here we are writing the equation N1, M1 equal to how much, like that we are just rearranging the formula, N1, M1 equal to this much you are getting. Again coming to this side, O2, N2, this triangle will take, O2, N2 and TP2, this triangle will take, Again as usual, as done we are this side, similarly we are doing this side also, that is cos theta equal to, okay, this we are finding out, adjacent side divided by hypotenuse, okay, and we are expanding this way, to get to O1, O2, N2, we are making this one, breaking, total this up to this plus this one minus this one will be over this one, like that we are writing it. So each component we are trying to get, this is R2 cos F1, R2 cos F2, this is L2 M2 equal to B2 plus S2 plus sin F2, this one, okay, this one, then O2 TP2 equal to R2, this is hypotenuse is O2 TP2 equal to, this is R2. So now we are substituting everything in a cos theta formula, so everything substituting, and the N2 M2 simply we are keeping it as it is, and we are rewriting again. So N2 M2 equal to how much, so we are rearranging the equation and we are forming the equation like this. So once we know N2 M2 and N1 M1 means this one, N2 M2 this one. So adding this one will be able to get D. Okay. The earlier case it was middle, that is why we have simply taken D by 2. Here it is not exactly not in the middle, that is why we are finding out the N1 M1 and N2 M2. So in terms of formula we have made it, and adding this one we are equating with D. Okay. So N1 M1 plus N2 M2 equal to D. In that case, we have to add this formula, this N1 M1 formula plus N2 M2. So adding this, we are getting the equation like that. From here we can find out the theta. Cos theta is this much. So theta equal to cos inverse of this much. So once we know the theta, as usual we have to go for the finding out deflection angle of first curve. This is theta minus F1. Theta, once we know theta, this is F1, automatically this will be theta. Once this is theta, this angle also will be theta. Since it is angle theta, this theta means theta minus F2 will be deflection angle. Here, as far as this curve is concerned, here theta minus F2 this angle. Okay. So once we know deflection angle of both, curvature, from there we will be able to find out the tangent 1 and tangent 2. So that is only the main thing we have to find out. We found out now. Then we have to find out, we should try to find out the horizontal distances, making triangles. So first triangle we can make this one. This is B1, S is there, S1 plus T1. So we can get the horizontal distance of this one as hypotenuse. okay, into cos f1. We can come up to this point, and from here to this t1 plus t2 cos theta, then here again hypotenuse t2 s2 and b2, okay, into cos f2, this f2 f2 cos f2. So we come up to this point. So adding all this thing, horizontal distance, I mean adjacent side distances, okay, we'll be able to get the distance of x. That is the distance between the point of intersection of first point and the second point. So once we know the x, we can add a1 this side, because different angle of crossing, we cannot take 2a, because this angle is, suppose 1 in 12 means this is different, this is different, this is maybe 1 in 8 maybe different. So a1 plus a2. So here x plus a1 plus a2. This will be overall. This is the way we are resolving, okay, to find out the overall length. Okay, now let's go to the next type. Next type is also crossover with the reverse curve, but between the reverse curve we introduce a straight. So in this case, how to proceed? Let's see. Okay. So this is the detailed drawing of this connection. Here we have two turnouts, but it's the same angle of crossing we introduce. Because of the large distance, we want to introduce a reverse curve with the straight in between. Okay. So the earlier case, there was no straight, there was a common tangent point. Okay, there was common tangent and there was a common tangent point. This center of the arcs connecting the both will be in one line. Okay, but here it is not so because of the introduction of the straight. Okay. This, of course, because it's similarity, this one, this is same angle of crossing here. Since same angle of crossing, and we are providing, same value of radius, so automatically, the center of the straight will be in the middle. Okay, midpoint. That is why we have put as d by 2, because this is total distance between the track centers d. Since it is symmetrical, the center of the straight, okay, that means the center of the entire connection, that will fall exactly in the middle of the the track distance. Okay, as usual, we should try to find out the distance x for the fixing the layout. Okay, the first we have to, for fixing for finding out the x. So for finding out the x, again, we used to make some triangles and we used to find out all horizontal distances. We'll add everything. But here again, the tangent length we have to find out. Here, tangent length of this curve and tangent length of this curve, we have to find out. But of course, since it is a symmetrical, this complete distance, up to this point will be equal to this P1 to this center of this straight will be equal to center of straight to the intersection point of the other point. So it is sufficient to find out this distance up to this distance. How to find out? Okay. So first we have to find out the diffraction angle. For finding out diffraction angle, we must know the angles up to the center of this arc. Okay. So for that, as usual, we have to make some triangles conveniently, and we should try to resolve, okay, diffraction angle. So here, in earlier case, there was a common tangent point, and these the O1 and O2 it was connected straight away it was passing through the common tangent. But here it is not so because of the straight in between. So here, because of the the one more angle, now we got some psi. So this angle we have to find out, So we have to make some equation for this psi angle. So for this, what we do, we first take this triangle O1 TP2 is that in this. So tan psi equal to this opposite side by adjacent side. So opposite side by side, how much it is? S by 2. because total is S, it's because it's center, so this will be S by 2, and your adjacent side is R, so tan psi equal to S by 2 divided by R, so psi equal to tan inverse of S by 2R. So we made this equation first. Now we make this triangle O1 LZ, this triangle. This is our included angle as far as this vertex is concerned, O1. And we make some equation for cos theta here. So total here angle is here because of psi, here total angle will be, now when we keep this is theta, so total will be theta plus psi. So cos theta plus psi equal to, so adjacent side by hypotenuse. So adjacent side is O1L divided by hypotenuse is O1Z. Okay. So now you have to first try to find out the O1L. So O1L, what we will do for that, as done in the previous cases. See, total O1M we take. O1M means that is O1N plus Nm. So minus Lm will be over O. Like that, we do some breakup. So O1N plus Nm minus Lm will be your this O1L. Okay. Since to get so conveniently we do like that, because Lm Lm is, it is d by 2. Okay, because it is center, because of the symmetry. Okay, this is falling exactly in the middle of the track centers, so that is why this Lm equal to d by 2. No. So Nm also we can find out because of this triangle, as done in the previous case. So this angle is F mid, this also F, this will be equal to, you can find out, sin m equal to B sin f. So from there we will be able to get O1L. So like that we have made the equation O1N plus Nm minus Lm divided by O1Z, that is hypotenuse. So O1N equal to R cos f, O1M equal to R cos f, because we take this triangle again. In this triangle, this is F. This also we have done the previous case, because this is F, this is F, this will be 90, because tangent 90 minus F, 1, this is 90 minus F, total is 190. So 180 minus this is 90 minus 90 minus F will be your F. So in this triangle, so O1N equal to R cos f, or this is R hypotenuse into cos f. Okay, when this is F. So then again we are coming to hypotenuse O1Z. So already we have equation, we have this triangle. Here sin psi equal to sin psi equal to opposite side by hypotenuse. So opposite side by how much? S by 2. S by 2 into that O1Z. O1Z equal to S by 2 sin I, sin psi. Okay, so this work out. So now substituting everything here, this angle is cos theta plus psi equal to, so entire the components are there, O1N, Nm minus Lm divided by O1 is, we are substituting it. Everything we have found out. O1N equal to R cos f, Nm equal to B sin f. This is B sin f. And O1 is equal to S by 2 sin psi. So substituting everything, we got this equation. Then from here we find out that theta equal to cos inverse of this much. So we are bringing the opposite side psi. Then theta equal to, finally we got this equation. So once we know the theta, we can find out the angle subtended center. That will be equal to theta minus f. When this is theta minus f, this will be your deflection angle, theta minus f. So now we can find out the tangent length. Tangent length equal to R tan deflection angle divided by 2. So we got it, t equal to or tan theta minus f divided by 2. Okay. Once this is theta minus f and this is f, automatically this will be theta, because sum of opposite internal angles equal to exterior angle. Once this is theta, automatically this angle also equal to theta. Okay. Anyway, we don't go this side because we want to resolve everything up to this point. But anyway, we need to know this angle, because this angle is theta, so that we'll be able to get this triangle. No, for taking this triangle, we can find out the horizontal distance. So now we got the theta and deflection angle, everything. So now we can try to find out the x. So from here, we make this triangle first. So this is your b. We can take from our this table of dimension, and then plus t. This is your hypotenuse. So b plus t. I don't even know cos of. So b plus t cos of equal to, up to this point we can come. Then here t plus s by 2 cos theta will be your up to this point. Then you can 2 times we can add it, so that you will be able to get the total distance here. That's what we got here. Okay. Once we know the x, adding this side a, we will be able to get the overall length. So we can interpose the distance, interdistance between the SRJ1, SRJ2. Okay, we can form the layout. Introduce the points on crossing in position, and locating the common, the center of this straight and the tangent point TP2 and TP3 will be able to form the curve, including the straight. Okay. This is something about this connection. How we got these equations and all. So once we got the equations, all formulae, simply for this situation, if we know if we are collecting our all site data, substituting all the values, we will be able to get the good dimensions. Okay. Anyway, one example also we can do here. The crossover is required to be laid between 2 parallel BG track 15 meter distance by means of 60 kg 1/12 turnout with a straight of 40 meter in connection. Calculate the required parameters for the layout. Also calculate the saving in overall length in this layout over a layout with straight line connection between the crosses. So here straight we introduce. So this is a given. Though we know the crossing angle for 1 in 12 is 40 degree 49. So AB distances, of course we can take from the table of dimensions. Where standard is available. So radius 400 we are we are keeping 400 meter, and S equal straight portion is 40 meter. So normally whenever we do the connection, we used to keep the radius at par to the radius of the turnout. 1/12 means normally 1/12 radius we used to follow. Okay. Or of course passenger line normally 1/12 radius. Of course there are some provision they are given minimum how much. That is because of any constraints prevailing. Okay. Otherwise 1/12 turnout radius we can follow straight away. Here they are taken 400 meters. Okay. So now psi value we are finding out using the relation. Then theta we are finding out, substituting all the values here. So now with theta we got around 70 to 20.5. Then tangent length we are finding out, this tangent length, or tan theta minus f divided by 2. So the tangent length is coming around 10.854 meters. Okay. Okay, now we can find out the x distance now. But in distance we are finding out first the distance up to this point, so that we can double it. We will be able to get total distance of x. So further we take this triangle first. Here B S T is there, but S is there, we can substitute. S means what? Suppose we want to introduce straight behind the heel of crossing, okay, whatever length you want to introduce. Otherwise, we want to start the connecting from the heel of crossing, S will be 0 here. Okay, as far as this problem is concerned, we don't provide any S. So B plus T cos of, up to this point we are coming. Then coming to this center, this is center. So here 2T, that means 2 times of T plus 2 times of S by 2. 2 times of S by 2, because center only, that's why taking the S by 2. So yes, so 2T plus S cos theta, we come up to this point. Okay, so you already know we have doubled, so you will be able to get the distance of X. Okay, so in the relation we got the X distance equal to 139.386 meter. Then overall, of course, we are finding out, X plus A this side, that side A, we are getting a total length that's equal to 173.386. Okay, this is total overall length. Suppose we don't provide this not like a reverse curve connection, we want to have straight connections. Okay, in this case, how much it comes, we can work out. And because of this reverse curve, how much saving you are able to get, that also you can work it out. That has been asked in this problem. This the overall length, of course, which straight means d cot of plus 2a. So d cot d, how much here, 15 meter. Cot of equal to simply number of the crossing, that is 12. So 2a, adding 2a, we are getting 213.979 meter. Okay, if it is straight connection. So saving, how much we got here, 213.979 meter. If you are providing a reverse curve with straight, as per this problem, 173.364, then we are able to get a saving of 40.611 meter. Okay, so this is a numerical example as far as this type of connection is concerned. Okay, this is the way we have to do it. Once we know overall length, we can fix the geometry on the field. Okay, this is something about it. Okay, next the same crossover is another type, that means the different angle of crossing. With the different angle of crossing, reverse curve and straight in between the curves, reverse curves. Okay, if that is the case, how to proceed, let's see. Okay, here slightly, it involves a lot of calculation, trigonometric calculation, because so when this angle of crossing is same, it will be symmetrical. So in this case, this center of the connections, will be exactly in the middle of the track centers. Okay, we have taken last design, we have taken as d by 2, but here I will not be d by 2. So according to the angle, sometime this will be either this way or that way. Okay, so that is why we cannot take only one portion. We have to deal on the both sides separately, and we have to equate, and we have to find out the record this one parameters. Okay, here you see this is F1, this is F2. Angle of crossing is different, and we have the reverse curve after the heel of crossing, and here also heel of crossing, and in between we have the straight. And when we are connecting the O1, O2, but it will not pass through the common tangent point, because since there is a straight, and also it will not exactly, because straight, it not exactly pass the center of the straight also, because because of the different angle of crossing, even you don't pass through the center of the straight. Okay, sometimes it will be more or less, it will not be exactly S by 2 distance. Okay, so that is why we have to do some a compromise, and we have to do taking so many ways and means, and we have to do find out our required parameters, particularly the deflection angle. Okay, we want to first we want to know the tangent of this one and this one. We need to know the deflection angles, and further we need to know the angles up and center. Okay, As usual, no, because of straight, there is an involvement of one psi angle is there, okay, which is connecting this one O1 O2, okay. Okay, so let's proceed. First, this side we will take. Okay, we'll proceed. And here, what you do to first we are finding, this psi angle. Psi angle equation we form first. This psi angle equal to means we take the tan psi equal to. So here TP2 is Z divided by the O1 TP2. Okay. This is the tan. The opposite way, adjacent side we take and we form the equation like this. Okay. So in place of O1 TP2, we are substituting R1. This is our R1 radius. Because two radius also differing here. Okay. And again, we take this side also. Now we can, for psi angle, we take this side also. We take this triangle. I mean, tan psi equal to TP3 and Z divided by O2 or TP3, and we make TP3 is divided by R2. Okay, here also tan psi equal to opposite adjacent side. So we form the another equation. So tan psi is this side, we make this equation, and another side we make this equation. What we do here, TP2 TP3 is there. So TP2 TP3 equal to S, because since it is not exactly in this line, O1 O2 not passing through center, so that is why we are not able to take exactly, simply we are not able to take S by 2. So what we do here, we are adding this one, TP2 is Z and TP3 is Z. So that means total length will be equal to, that will be your S. Okay. Anyway, okay, now we are adding it, and both TP2 is Z, TP2 is equal to R1 tan psi, and TP3 is equal to R2 tan psi. So adding that, we have the equation here, TP2 is Z plus TP3 is equal to R1 plus R2 tan psi. We have that. Okay. Now what do you do here? Yes, already told you, this TP2 is TP3 is equal to S. So S is equal to R1 plus R2 tan psi. Okay. So from there we form the equation tan psi to S by R1 R2 and psi equal to tan inverse of S by R1 R2. So now we made the equation of psi. Okay. Now what to do? We take this portion, and in this portion, we take this triangle O1 is Z En1. So O1 is Z, okay, N1. This triangle we take. This triangle, as already discussed in the previous connection and all, so we take this triangle, this triangle, this is your included angle. That means it's theta plus psi angle. So normally cos formula we are using it, and we form some equation here to find out the angle theta. Okay. Here anyway, this O1 N1, we cannot directly get it. We O1 M1 minus N1 M1, like that we make, and L1 M1 we know, taking this triangle, and O1 L1 we know, taking this triangle. This all already we have discussed same way only, because this is this F1 angle, how we got F1, this is also F1, this is 90 minus F1, total 180, so 90 minus F1, 180 minus 90, 90 minus F1 will get F1. Like that we take this triangle, this is F1, automatically this will be L1 M1 equal to, so what is this? This is so L1 M1 is B1, suppose S is there, B1 S1, this sin F, okay, sin F1, okay. If it is S is there, S is not there, simply B1 sin F, okay. So from this we are making this equation cos theta plus psi. That means cos theta psi equal to adjacent side divided by the hypotenuse. So we make this equation. Okay, this is O1 N1 equation. This is components. This is O1 Z is this one, O1 Z hypotenuse. So once we form the equation, okay, that we are naming it equation number something. Okay, this is cos theta, because we dealt this portion, and from this triangle we made the equation cos theta plus psi equal to something. Okay, like that we come to this side. Similar way we have to do it. Okay, take this triangle O2 N2 Z. We take this triangle. Again theta plus psi will be your this included angle of these vertices, and again cos theta plus psi equal to adjacent side divided by hypotenuse. Adjacent is O1 N2, that you have to find out similar way. Total minus, okay, this portion, okay, this N12, okay, again we are breaking this one L2 M2, okay, something like that. So similar way we do it, and we make the equation cos theta plus psi equal to R2 cos of something B2 plus S2. If S is there, otherwise we can simply ignore sin F2 minus N F2 O2 Z. Okay, so we have made an equation cos theta plus psi used from this triangle as well as from this triangle. We made it. Okay, now here this the part unknown part is here N1 M1. Okay, here N2 M2. Okay, this is not known. Earlier case we have taken simply d by 2. Here we can't take, but adding this both component we will be able to get d. Okay, N1 M1 plus N2 M2 equal to d. So now we are rearranging the two equation in the form of N1 M1 equal to, like that. Here this equation N2 M2 equal to, like that we form the equation. Once we form the equation like this, the d equal to N1 M1 plus N2 M2, so that will be equal to d. So now adding this equation, okay, we have one okay, the equation. Here the equation unknown is here, other thing and all we got this O1 Z plus O2 Z. That is actually O1 Z plus O2 Z is total. Okay, this total length, that is O1 O2 actually. So this we are getting it. How we can use this psi formula? No, this sin psi equal to, here we take TP3 divided by TP3 Z divided by O2 Z. Okay, sin psi equal to TP3 TP3 gives TP3 Z divided by O2 Z, like that. This here also we take. So TP2 is equal to O1 Z plus O2 sin psi. Okay, so this is an equation. In that TP2 Z, TP3 Z equal to S. So S equal to O1 O2 is sin psi. So what do you want? We want to know O1 Z. So O1 O2 equal to S by sin psi. So wherever we have the O1 O2, we have to substitute with S by sin psi. Okay, so substituting all, so we made the final equation here. This will be our cos theta. Theta equal to cos inverse of this portion. Okay, so finally we got the theta. So after that, once we know theta, as usual, we can find out the T1 here, because deflection angle equal to this angle subtended center. So theta we got, theta minus F1 will be your deflection angle here. Then the tangent length equal to T1 equal to R1 is R1 tan deflection angle divided by 2. That means theta minus F1 divided by 2. Okay, like that. So T2 is equal to, so here this portion, this is R2 tan of deflection angle theta. Here already you can know theta minus F by 2, that is our angle subtended center, that will be your deflection angle here, theta minus F2. So T2 equal to R tan theta minus F2 divided by 2. Okay, got it. So once we know the tangent length, so we can now make some triangle where we can find out the horizontal distance from the point of intersection of this point to point of intersection of the other points. Okay, first triangle we take here, B1 S1 is there, you can add S1 also, and T1 cos F we got up to this point, then T1 here plus S, and T2 cos theta will be your horizontal distance up to this point we come, then we can go from here T2, S2, B2, cos F2, this is F2, this is also F2. So we have come up to this point. So adding all, we are able to get the x distance. Once we know the x distance, adding here A1, this side here 2, we'll be able to get the overall length. Okay. Since it is not 2a, since because the angle of this crossing, the different angle of crossing, this will be a1, this will be a2. So 2a will not be there. OL equal to x plus a1 plus a2. Okay. This is all the equations. Okay, we got it for solving this type of connection to find out the x distance and the overall length distance. Okay. Once we got it, as usual, we can fix the SRJ of one point if it's known. From there, we can fix the SRJ of other points since crossing, and even this center, this also we can locate. Okay, solving by triangles, portion by portion, we'll be able to locate each point. This point we can locate, this point we can locate. Okay, then this everything. Okay, this is very simple. So once you understand, this the principle, logic, whatever you used, and you'll be able to proceed as per your wish. Okay. So even the field data, you can whatever data what you are collecting from the field, and with that you will be able to get the required dimensions, and you can fix the geometry on the field. Okay. So next, cross over the different angle of crossing, how to proceed, we'll see. Okay. So this type of connection, this is also a crossover with a different angle of crossing on both lines, but without any reverse curve. So if you want to connect it, how to do the connection and get the required dimensions. Okay. Since the angle of crossing is different, we cannot have the straight connection. Because of the difference in angle, there will be change of direction, and necessarily it will require a connecting curve. Okay. So this is the D is of course known, let us take, and if we want to provide S1, we can provide, because normally the distance is large, then only the S1 will be able to provide, but the distance is short, so we can't accommodate any straight. Okay. Anyway, just we will proceed. So first, for providing normally connecting, or what do you know? See, radius is known. Radius must be known. Suppose we have the radius, known radius. Suppose this is a passenger running line. So we want to introduce a crossover. Necessarily, the connecting curve also should be at par to the 1 in 12, because 1 in 12 radius. Normally, that is desirable. In case any space constraint only, then we used to go for the some slightly sharper. That means we can go up to 220 meter. Okay. That is as per the Indian Department manual provision. Okay. Suppose we want to provide the 1 in 12 radius. So radius is known. So we can find out the T, tangent length. Tangent length equal to R tan F1 minus F2 divided by 2. That means here, this is your connecting curve. This will be deflection angle. So R of tan deflection angle divided by 2. So how we are getting deflection angle here? Because this is F1, if we are extending it, this is also F1 now. Okay, this is F1, and when this is F2, different angle of crossing, automatically we will be able to get this angle, this triangle, because normally this triangle, the exterior angle equal to sum of opposite internal angles. So suppose when we know this angle, so this angle minus this will be our deflection angle. That's what here. This will be F1 minus F2. So that's what here written. T equal to R tan deflection angle F1 minus F2 divided by 2. Now we got the tangent length, so we can make some triangle. We can find out the horizontal distance up to this point of intersection. Okay, from point of intersection 1. So x distance, okay, we can take this triangle first. Here, suppose if we have yes, we can have, otherwise we can ignore this yes also. So B1 plus S, okay, S1 plus the T hypotenuse of cos F1. We can come up to this point, okay, horizontal distance. Then from here, this point to this point, we can have the horizontal distance. That means hypotenuse is this is T plus S2 plus B2 cos F2 will be your horizontal distance. So adding both, we will be able to get X distance. Suppose you want to know our overall length, X plus A1 plus A2, because since different angle of crossing, A will differ. That is why here X plus A1 plus A2 of this point. Okay. This is the way we find out. Sometime will come in a reverse way also. Suppose we want to get the tangent length for the available D. So what's the curvature we want to provide? We can work it out here. So we can equate the vertical distance with the D. You found out horizontal distance. We used cos formula. We want to work out the vertical distance. Simply you have to change the formula of the sine. So B1 plus S1 plus T sine F1 and T plus S2 plus B2 sine F2. That will give the total vertical distance that we are equating with the D. Okay. Then from here we can find out the T how much we should provide. Once T is known, from here we can find out the R how much radius we are getting for the available radius. Suppose full curvature we are providing. That also we can get it. Okay. Anyway, we just see work out example, then you can understand in what way these formulas are useful. So in this case, first example, a crossover is required to be laid between the two straight parallel tracks at 4.725 meter centers by using a 52 kg 1 8.5 and 1 in 12 turnouts. Calculate the required parameters for the layout. Okay. So they are given all details here. A distance, B distance, and the angle, crossing angle for 1 8 and 1 in 12. Okay. So now, we assume that there is no S, we don't have. We take only B plus T. Okay. This side also we don't have any S. After the heel of crossing, we don't provide any S. So now we are finding out the how much radius we can provide. Just we are finding out for this distance 4.725. So then we equate the vertical distance with D. That formula we have. From there we get the T. Get the T. So using this formula we are getting 3.492 meter tangent length. For the tangent length, we work out the radius. It comes to 205.597. Whereas it is very less, because normally for passenger running lanes we used to prefer only the radius of 1 in 12 turnout. That means 440 something, that radius we used to prefer. But however, in case of any space constraint is there, we can go up to 220 meters. Okay, as per the Indian Permitted Manual provision. But this we cannot provide. So that is why now we have to for getting our minimum radius we can work out. So what should be we can go reverse also. Okay, we can find out the T. From there we can find out the minimum distance how much. Okay, like that we can find out. Is also possible here. Anyway, let us go to the next example for that. The same problem, what we have seen earlier, that so 1 in 12 and 1 in 8.7 we have, but we want to provide radius of 1 in 12. That means 441.282 meters. If that is the case, what should be the minimum distance between two tracks you have to keep? So as told earlier, now we can find out. So we have to find out the tangent length for the crossing available. for the curvature, connecting the curvature. Okay. So we are getting 7.495 meter is our tangent length here. Here also we assume that there is no S between the heel of crossing and the tangent. Okay. Begin the heel of crossing, we don't have S in both the crossing. So we are working on D now. So T already we have found out for the 441 to 282 meters. T we got it. And with the T, we are working out the D, how much, the minimum D, how much we require, we are finding out. That means any vertical distance equating. So D equal to now what is sine of formula. Okay. So B plus T is sine of 1 plus T plus B2 sine of 2. We will get the vertical distance equating with the D. So we are finding out the D. So here in this case we require a minimum distance of 5.52 meter for accommodating the 1 in 12 radius of curve. Okay, this one. So we are okay. For that we have to plan and keep the track centers accordingly. Then for fixing the turnout, crossover, we need to know the x distance and overall length distance. So again, this formula we are using as usual. Horizontal distance we are finding, same formula we are finding out the horizontal distance B1 T cos of 1 T plus B2 cos of 2. That distance, this distance will get. Adding both side A, that A1 plus A2 will get the overall length. That comes to 82.062. The x distance is 56.110 meter. And adding both A1 and A2, we are getting 82.062 meter. Okay. So for this condition, we need the minimum track center of 5.52 feet. Okay, that should be ensured in case of different angle of crossing, particularly 1 in 12 and 1 in 8.5 crossing, and with the radius we want to use provide equal to 1 in 12 turnout radius. Okay. So this is something about the problem, and with this data we can fix the geometry on the frame. Okay. So next, crossover between the main line and the loop line with a different angle of crossing. Okay. But symmetrical split here. So I told symmetrical split where we are providing almost all stations, particularly the wayside stations and all for isolation purpose, and we used to provide the stacked detent at the end of the loop line. Okay. Whether it is a double line or single line. Okay. In single line means all four sides will be there. Double line means only directional movement side will be there. Okay. So in this case, as already discussed, normally we used to prefer this one in of points of crossing, and that will be laid as a symmetrical split in order to get the advantage of 1 in 12. The less space we are able to get the advantage of 1. That means we are able to get the turnout radius equal to 1 in 12 when you are laying as 1 in 8, symmetrical split. Okay, that already discussed, So if that is the case, how the layout is fixed on the ground, or for that how to get the required parameters, x and overall length you can find out. So like a previous case, different angle of crossing, that we have to follow that here. Earlier up to this, now this way. Suppose when we are providing 1 in 8 of symmetrical split, let us take this is 1 in 8 of crossing angle. The angle will be divided by 2. Okay, since it is symmetrical split, this equal diversion takes place. The angle will be half of the crossing angle. That will be f1 by 2. Of course, here 1 in 12 crossing means f angle. Let us take. Okay, and with this condition, okay, and providing a radius of 1 in 12 radius, turnout radius, and how much s you can provide or no s, 0 s. Let us have to calculate, and also you have to find out the x distance or distance. We'll see a numerical example also. Okay, this is V. So this is detailed drawing here. Okay, here this is a line extension. Since it is not angle not equal, definitely there will be a change of direction and needs a connecting curve here. So you have to find out the T, Okay, for that you need to know the differential angle, and we make triangles and finding out the horizontal distance. Okay, so here this one like this. So t equal to here r tan f1 minus f2 by 2. That as previous case, the different angle of crossing. Okay, so this is f1 means what will this angle will be equal to this extension we are making. Suppose we are f1, this f1. So this is f2. So this angle will be equal to f1 minus f2 by 2 will be differential angle. So that's what here. So divided by 2 will be your r tan will be your tangent length. Okay. So then again we have to find out, as usual, that we have to find out the x distance. So cos formula we are using, this triangle hypotenuse into cos of, and this triangle hypotenuse into cos f2 by 2. Okay, this angle will be equal to f2 by 2. So we will get the x distance and overall length equal to x plus this here a1, here a2. So we get this one. Suppose we want to know the s distance, how much and all, we can find out here. Using the vertical distance equating to d, that means same formula we have, we are writing in sine formula and equating the d. In that we can find out the s distance, how much s distance we can keep, that also we can work it out. Okay, so reverse we have got it. So this is something about the derivation of the formula as far as this connection is concerned. Okay, right, coming to the numerical example here. See, a crossover is required to be laid between a loop line, a parallel main line, 4.75 meter traction interest by using 20 kg. 1 unit of here loop line 1 in 12. Okay. Okay, this is for 1 unit of symmetrical split in a loop line 1 in 12 and a main line, and radius of connecting will be equal to radius of here 1 unit symmetrical split. Calculate the radius parameter. 1 unit symmetrical split almost equal to our radius of 1 in 12 only. Okay, anyway, it is 464.07 radius. That means it is a double the radius of 1 in 8.5. Okay, this one. In this case, how to proceed? So work out the tangent length using the formula r tan f1 minus f2 divided by 2. So we get 5.705 meter will be our tangent length. And s distance we are finding out now. This as derived earlier, s equal to this much, and we are finding out 4.98 meter s distance. So x distance equal to all horizontal distances, making triangles. So b1 s plus t, yes, we are finding out now 4.89989, and t cos of 1 plus t plus b2. Here f2 by 2. Okay, I think we don't provide any here, straight here. Only one side we are providing it here only. We don't have. So t plus b2, f2 by 2. So in this case we are getting x equal to 64.1. It's complete trigonometry. See, according to situation, and you can make your formula like that now. You can, if you want to put s here, b plus s you put. If you want to put here s, then t plus s plus b, like that you can add it. Okay, if you know s is required, you just forget about the s. Okay, we don't want to provide s. Okay, then we can work it out also accordingly. We can, in the case tangent will be more from here to here will come. Here also will here come. Like that, just trigonometry, applying what trigonometry in mind, and we'll be able to resolve, make your formulae, and you get the required parameters, okay, for x and overall length for geometry on the field. Okay, this is something about the symmetrical split. Okay, next is the crossover between non-parallel tracks. Suppose, okay, as I told always it cannot be parallel, sometimes it may be non-parallel. In this case, how to proceed, okay, and how to get the required dimensions or parameters. Okay, let's see. So in this case, actually D minimum for so getting this type of connections and where you have to locate your SRJs. Okay, so further we require minimum distance. We cannot provide very close also. We cannot provide it. Okay, that's a minimum distance. How much is required also we can find out this. Okay, and this is one way of okay. Resolving, and other time also, other way also. Suppose D is somewhat for okay, comfortability is there. In that case, how to do the connections also can get it. Okay, so both way we can do it. Okay, so then this is a detailed drawing of this connection having non-parallel track and introducing a crossover between them with a different angle of crossing. So this is a line with the reference to this line. There is inclination of delta as far as the other line is concerned, and so we keep the SRJ of the inclined line and this line. So we take it as D. Okay, this is a minimum distance. Then the crossover. This is our minimum distance. That distance we are keeping. Okay, we are measuring. Okay, this is equal to D. Now for doing the connection, as usual we need to know the x distance. That means the distance between the point of intersection of point number 1 and 2. Okay, so once we know, we can find out the distance between the SRJ. That means overall length. Okay, that x plus a1 plus a2. So we have to find out the x. So finding out the x, as usual, we have to make some triangles and find out the this horizontal distances. And because of the inclination, and some additional work it will involve and we have to do. Because see, for this hypotenuse as far as this triangle is concerned, here we know B1, that is standard dimensions. Yes, of course, if we want to have, yes, we can have, otherwise we can make it 0. And this is a tangent length, whatever curvature we are proposing, and further we have to find out the tangent length. Okay. So further, we need to know the deflection angle here. How to find deflection here? Okay, since it is not parallel, okay, that is why the deflection angle equal to, suppose when you take this triangle, when we know the exterior angle, this angle minus this angle will be your deflection angle, already we discussed. That means the exterior angle equal to sum of opposite uniform angles. Okay, so this angle minus this angle will be your deflection angle. This angle is how much? Okay, it is not running parallel to, okay, this line is not running parallel to this line. That is why I am drawing a line here parallel to this line. So this angle will be equal to F1. F1 means this also F1 because it is a alternate angle. Okay, then this angle will be equal to delta inclination. Okay, because when let us take here, when it is drawing here, this will be your F1, this will be your delta. That means this angle will be equal to F1 plus delta. Once we know this angle will be equal to F1 plus delta minus F2 will be your deflection angle. Okay, so this is your deflection angle. So from there you can find out the tangent length. Okay, so first let us make an equation for tangent length. P equal to mod tan of delta plus F1, that means this angle, minus F2, this angle will be your deflection angle, divided by 2. So tangent length we got it. So after what we do, suppose we want to find out the x distance. Let us first find out the x distance. Okay, that means we have to find out the horizontal distance of the triangles. So first triangle when you take here, b plus t, b1 plus t. If s is there, you can add s also into cos f1. We can come up to this point. Then from here to this point of intersection, we have to go. The horizontal distance we have to find out here. B2 t, here t, this is t plus b2 into cos f2 minus delta. So here this angle is equal to f2 minus delta because it is not this f2 is equal to not parallel to this line, it is inclined, So this angle will be equal to f2, and we are drawing a line here, a parallel line, this point, this angle will be delta. So the final angle equal to what is f2 minus delta, that will be your angle here. So cos of f2 minus delta. So this is an equation for x. So we found out now x distance. Then adding your this side a1 and a2. Since due to different angle of crossing, the a1 a2 will differ. Okay, that's why x plus a1 plus a2. We will get finally the overall length. Okay. Then suppose we want to find out the distance s. That means heel of crossing to the tangent point. We want to find this. So we can find using the relation, this one. That means this equation you are forming here, two way it will be helpful. Sometimes we want to find out the minimum D, how much minimum track center you must ensure here for performing this connection, So we can avoid this here, 0. So in this case you can put B1 plus T sine F1, we can come up to this point. Then here T plus B2 sine F2 minus D. That means just same formula we are making a sine formula. Okay. Then minus A2 minus sine D. So okay. Minus this height. This height, up to this we have come. Then we have to deduct this height. This will be equal to A2 minus. Sorry. This will be equal to A2 sine delta. So once we do that, we will be able to get the distance. This will be minimum distance for performance connection. Suppose we want to introduce yes. Suppose we have some comfortably some spacing is there. Then we want to, after the curvature, we want to introduce some slight in between the heel of crossing and the tangent point. Here you can add yes. You can add b plus s t sine of something will get. D already we are it's known. So substituting here, you can find out the yes from here. Okay. This is a way we can interpret, okay, to find the required parameters for performing the connection. Okay. Now we will go to the example here. It's a crossover consisting of 2 gauge 1 in 12, 1 in 8.5 turnouts. Is required to be laid between non-parallel straight track. Okay. The inclination angle is equal to 3 degree 50 minutes. Radius of the connecting curve is 400 meters. So we have to calculate the required parameters. This is the thing. Here see, here we are performing, first we are calculating, here they asked minimum distance between two tracks. That means how much, the minimum distance we have to find out. At what distance we have to keep our SRJ, the inclined track. Okay, we cannot keep very closer, okay, closer. That is the case, we can't get the perfect connection. That is why minimum distance, otherwise it will overlap, that is why minimum distance you have to find out. And for that, this is the data available, given, okay. A and B and all you can take from table, and this is crossing also 1 8 and 1 8 12. Of course, this is B and all, this is what they have put for the non-PSA layout, maybe, okay. So now we have latest for CMS crossing with the PSK. For that value you can take. This is old value anyway. For example sake only we are doing it. Okay. So we are finding out now T equal to R tan delta plus F1 minus F divided by 2. Using the relation we are finding out the tangent length. So R we are substituting 400. Other thing we are substituting, we are getting a tangent length equal to 20.191 meter. The D minimum we are finding out. You can using the second equation, D minimum equal to sine formula, okay, from here to here, sine formula, and minus this height, this delta, this sine delta A2 will be this. If you are deducting this, you will get the distance, minimum distance we are getting. So substituting all the values here, we are getting D minimum equal to 3.978 meter. But however, normally between track center we used to have minimum distance of 4.625, that is there. Okay, that's we are supposed to follow. Okay, anyway, here as per this problem, it's for 3.978 meter. And so that if you are fixing it exactly, the we'll have the heel of crossing, then connecting curve, perfect connecting curve, then the curve exactly it will join a tangent point, heel of crossing. Okay. So now x equal to x formula, cos formula we take, and we are finding out the x equal to b1 plus t cos f1 t plus b2 cos of f2 minus delta. Okay. Substituting here we get 81.517 meter. That is x distance. Then once we know x distance, we can find out the overall length. X plus a1 plus a2 cos delta. Here a1, here cos delta we have to use because it is not horizontal, no. It is only inclined. Horizontal distance equal to a1 cos delta. Okay. So using the relation, we are finding out the overall length, that is equal to 110,432 meter. Okay. This is something about the example. As far as this non-parallel track is concerned, introducing crossover, the different angle of crossing, and providing a kinetic curve in between them. Okay, to find out the minimum distance to have the required radius. Okay, that 400 meter radius. No, for fitting that exactly at the tangent points will be your hills of crossing. Okay, this is something about it. Okay, so far we had seen parallel and non-parallel track, connections and crossovers. Okay, but regarding the curved track connections, we'll see in the next video. But let's see something about the software applications also. So just I will show what I am having in my website. Okay, there I have this live calculation design. So this is my website name, that is https V.Thiagarajan.com. Okay. So there I'm having applications and videos also. I put something videos and quizzes also is there for some railway topics. And now go to the applications. I'm in that I am having so many applications: earthwork calculation and longitudinal track profiling and realignment of curve and setting of curve. IRSE design also, simple design and all I made it. And last layout railway. It is only I made so far. At present I'm having only the connection to divergent track and parallel non-parallel tracks. Okay, curved track connection so far I not included. Shortly I will just that also will include. Okay, so we'll go to this one. Okay, just one or two will see, so they have some idea. So you can make use of these applications, and it is only online applications. Okay, so once you have the internet connection and you have anywhere, you can just open it and do some calculation, do some design. Even mobile also. Okay, it's possible once you have the net connections. Okay, one bit section. Okay, so this is coming to divergent track. We have three type. LDCE. This is angles are same. Okay, both angles are same. This thing simply I put one unit off. This angle also one unit off in this case. Okay, default I'm just putting in there. Then I'm just clicking this one. You get this one. So there is no need of any length and all. Straight away, you can extend it, and only this from the point of interest you can add a distance. You can fix the SRG. You can do the connections. Suppose you have one unit of some what do you call next is the angle of inclination is more than the angle of crossing. That means let us take some custom. You can put also some. You have some 10 degree. Let us take, but whereas this is 1 in 12 cross, we are using it. So this type of connection you will have it. But radius of connecting you are providing 1 in 12 radius we are providing. Okay, or whatever you can just enter here. Okay, once after feeding everything, if you are clicking the design, you will have it. Okay, so SRJ to point of intersection, this is E, then tangent, whatever tangent length, then whatever you have. Okay, it's calculated, and the x distance calculated, and overall length and y distance. Once you are knowing your overall length and y distance, will be able to fix this tangent point. You can do the connections. Suppose even can go to the drawing also, it will just print everything and drawing, and all details will be available here. You can just write whatever you want. You can take some printout also. Okay, this is something about it. And like that, suppose suppose you have 1 in 8.5 crossing. This angle is some only 4 degrees there. This is 6 degree. Okay, in this case how to do it? 4 degree. Okay, this is 1 in 8.5. Okay, some, that means here angle is less than your angle of crossing in this case. this whatever even you can give 1 unit of this curvature also you can give 220, 231, and whatever you want, that also you can custom. Your curvature also you can, radius of curvature also you can feed here, you can design. Now you got it everything. The overall length is now what to do 571, and y distance. So fixing here you can get that. Radius, how much you are providing, consistency drawing also you can go there. So here entire thing you got it. This radius of curvature 231, and overall length 42 something, and y distance 3.3 meters. We'll have that. So like that you can do it, and you can go to the other type also. So parallel track. So it's a normal track. Simply case, we have a lot of cases, 3 cases are there. First case 1. This is suppose both side we have one. This is only 1 in 12. Let us assume we have the 1 in 12 radius. We don't put any. If you want to have any station, you can put. Otherwise, just leave it after this one. Or you can put something 6 meter also. You can enter it, whatever side you want to have it. And distance between track is 5 point. Let us add. And I don't put any S. Let us see here. This is okay. Now only one tangent. This is tangent. Length, everything got it. Overall length, how much? 98.9 something. And straight length behind the heel. Even you don't put it, will give you something. Reverse curve is no reverse curve and all. So everything you got it. You can go to the drawing also. You can just entire thing you got it now. So this is something about it. Then if you want to have case 2 also, it is only reverse curve. Reverse curve. 1 in 12, same thing I am having. Track center, let us have some 10 meter. 10 meter, you put everything in mm. And begin the zebra crossing. Just leave it. Let us see what it gives. So it is not giving taking any zero straight is providing, and you will have the reverse curve here. It's having 2 tangent, tangent 1, tangent 2. All this thing you got it. So overall length you got it. You can fix it. This is one type. Another type is you have this is with the straight in between. So let us take here some 30 meter. Let us take 30, 1, 2, 3, 30,000. Straight, let us have 6 meter or some 10 meters. You can put 10, 1, 2, 3. All should be in mm only. So one dial you can put 13 meter. 13 meter. 13 meter. How much? 13 meter is there or too much? 13 meter. Now you can do the design. So you got it now. 13 meter straight in between. And this is your overall length. So distance between tracks 30 meter, and straight is 13 meter. Even behind this also it is given 12 meter. It is given, and tangent length. So it's giving all details. Now like that you can go to different type of connections we have. You can make use of these applications. Even between parallel track is a crossover also is there. Simply we do 1 in 8 and half, 1 in 12 both cases. Distance is 5.3. Simply d cutoff will come, D cutoff means what? 12 into D 5.3. Suppose 6 meter will put a lap. So 12 into 6, 72 meters it has to come. Okay, 72 meters, 72 something, x is you got, then adding this side x, okay, this side a, that side a, it will give you overall length. Okay, overall length how much you got, see 105 something got it, no, some 16 to 16, 17, 17, 34, adding it, you will get this one, you got it. Suppose another case, there are a lot of cases are there, this case is with reverse curve, and another case is reverse curve with straight, and fourth case is different angle of crossing, how to do that. Okay, so in this case we want to introduce a crossover with different angle of crossing on each line. Here suppose when we use here 1 in 8 no points on crossing, here 1 in 12, so automatically it will not be straight, connection will not be straight because of the change of angle, there will be a change in direction, so necessarily we have to introduce a connecting curve here. So in this case how to proceed here, see, let us take here f angle 1 in 8 half, here 1 in 12, let us, so 60 gauge CMS, let us have as it is. Radius what we are fitting, we are going to fit, let us take some 1 in 12 radius, let us provide. Okay, then distance between the tracks, let us take 6000. Straight behind the crossing, I don't want to have any straight behind the crossing, let it be 0. Okay, okay, and both sides. So now we'll calculate, some message is coming on. Minimum required distance between tracks 6167 mm, or increase the distance. Okay, if not, reduce the radius or reduce the straight, make straight is equal to 0. Okay, so either you can increase, suppose let us have 6 meter only, we cannot increase. Suppose we want to reduce there, you can reduce the radius, let us put some 350 meter radius, like that. It should be in mm. Okay, no straight in between. Okay, that's okay. Okay, now we got it. So now we got the result. Okay, radius of connecting curve we are providing 350 meters, and of course overall length and all we got some 88 meters we are getting. Okay, this is only one. Okay, this is a way you have to calculate using this application. Drawing, coming to drawing, it will give you all details, same thing, and all dimensions you can, whatever input you are given, whatever the results. Okay, you got it here. Whatever you want to enter, you can just print out. Okay, this is something about it. Now of course case 5 is it is a different angle of crossing with no straight in between. Similar way you can do it. Then next this is different angle of crossing, the straight in between the reverse curves. Okay, this is another option, you can do it. Case 4 it is a symmetrical split. Okay, so symmetrical splits also you can do it the same way what we have done. There are different angle of crossing, same way. Here some 1 in 12 let us have here f, then here 1 in normally our symmetrical split, so 6 meters let us have that. Here 1 in 12 radius we can provide. Would refresh. Okay, so sorry, 1 in 12 radius. Okay, so no straight, let us design now. So we got this result. So this is symmetrical split. So 440 meter we are giving the radius. Okay, 1 in 12 radius. Then everything overall length also we got it. Here overall length is some 108 meter, like that. Okay, so we don't provide any straight behind the heel of crossing. We have to simply start after that. If you want to introduce, you can introduce a straight also. Okay, this option. So this is about this symmetrical split. So we'll go to the next. That's all. Max option is only available. That's all. Okay, we'll go to the next type. Here you can go to non-parallel tracks. Here non-parallel tracks. Here we got two types. Now case 1, case 2. Case 1 is, suppose we know the this inclination angle. That means this is one line, another line is non-parallel. Okay, so how much the deviation? Okay, inclination we have. If you know that, we can use this option. And suppose normally if we want to find out the d minimum, we can find out, or we can, if just it is comfortably the distance is there, so you can feed this distance and you will be able to get the, once we know the angle of deviation or inclination, entering this in, we will be able to get the complete parameters for performing this connection. Suppose let us take here 1 in 8.5, let us take both sides 1 in 12, let us have here also 1 in 12, so 60 kgs, radius we are fitting 441, so distance between tracks 6 meters, let us have it. So angle, if you know, you suppose directly you can get some 3.5, 3.83 something is there. Okay, so no straight, we'll try now. So we got it. Okay, this case 1, suppose to get the d minimum, this is this thing, this case 1. Okay, suppose our next case we'll go here and 5.3 is angle is there. Let us work out here. Okay, this way you are getting it. Okay, the first option is only for d minimum, how much to get that first option. Second option is for knowing the d. Suppose we are fixing comfortably the d and we want to do the perfect connections. Here you can do two ways. One is giving the inclination angle directly we can do, or if you don't know the inclination angle, we can measure the distance. Suppose let us take this is a place we want to introduce. Here we measure the distance, and another distance we measure between the track centers, and this distance between the point where you have taken the distance, that also you have to measure. For all values, if you are substituting, will automatically to work out the inclination angle, and it will find out all required parameters. Okay, this is another way. So we can go to this side. So it will give all details whatever you want. Okay, this we can make use of it. This is something about this non-parallel track. Okay, types. So this will conclude this okay video subject, and this is my mobile number and all, and even you can refer my email address also. If you want to give any feedback, you can just give me the feedback about this application as well as this topic what we discussed. Okay, we will meet in the next video. Okay, thanks for watching. Thank you.